Hey everyone, today we will be multiplying and dividing algebraic fractions. So just like how we would deal with normal numbers, normal fractions, when we multiply and divide by algebraic fractions, we're following the same rules. When we are multiplying fractions, algebraic fractions, just like with normal fractions, we just multiply across. So p over q times r over s is just p times r for your numerators, divided by q times s for your denominators. So in using an example here, 3/4 times 2/5, you just multiply across, 3 times 2 on top, 4 times 5 on the bottom. You get 6/20, and then you can divide top and bottom by 2 to get 3/10. With division of fractions, you'll remember that you have to flip the second number and multiply. Same thing with algebraic fractions. So p over q divided by r over s would be the same as p over q times s over r. So changing that division to a multiplication because it's reverse. And then you multiply across, p times s on top over q times r on the bottom. So with our example with normal number fractions, 7/8 divided by 5/4 is the same as 7/8 times 4/5. And then you multiply across, 7 times 4 is 28, over 8 times 5, 40. Reduce further by dividing by 4, top and bottom. 28 divided by 4 is 7, 40 divided by 4 is 10. So that's how you get 7/10. All right, so we're going to use these rules that we've learned from before, and now we're just going to apply it to algebraic fractions. Go ahead and pause the video and try A, B, and C here from example 3 on your own. All right, let's do A together. So this is multiplication, so we're going to multiply across. 3x times 2 is 6x over 8 times 5 is 40. And then I have an x by itself, and I have two y's. Y times y is y squared. Now at this point, I can actually reduce some, because remember, any number divided by itself is equal to 1. So I can cancel them out because that won't really change the value of my answer. So I have x over here. Okay, so then x over x would cancel each other out, and I would end up with what's left over is 6 on top and 40 on the bottom, y squared. You're probably thinking to yourself, but I can reduce 6 and 40 because 6 can be reduced to 2 times 3. And 40 is 2 times 20. So then both those 2's can be canceled out. I can use my blue so you can see that. 2 and 2's cancel each other out. So then finally at the end, I have an answer that is multiplied and reduced. So I get 30 over 20y squared. Nothing else I can do now. Nothing at all. 30 and 20 don't have any common factors, and then y squared doesn't have any y's to cancel out on top. So that's your answer for A. Let's take a look at B. For B, we can multiply across, or if you already see that there are some common factors that are shared by the top and bottom, like for instance, it's a squared, and this a squared can cancel already. Yeah, you can do that. And so when we multiply across, we just have 2 times 3 left over and all that, okay? But if you don't want to, you can just multiply across already and then deal with it afterwards. 2 times 3 is 6. A squared is by itself. B times another b is b squared. And then just d. So that's on top, and on the bottom we have 5 times 8, which is 40. A squared and then c cubed d squared. Okay, and just like before, I can go ahead and cancel out these two a squares. They're already set up for me. And then I can actually break it down further, okay? So 6 and 40, they both share, wow, I got 6 and 40 just like the previous one. They both share a 2. 2 times 3, 2 times 20. And over here, you could break it down like this so that you expand all your variables and cross it out that way if you like the satisfaction of crossing them out. 2's and 2's, D and D, crossing it out like that to get your answer. So at the end you have 3b squared over 20c cubed, because there's 3 of them, times a d left over. There's nothing else they share. Now if you don't like that, remember you know your shortcut from your exponents. So if I have d to the first power here and d to the second power on the bottom, I know I can subtract. So with my d's, I would have d to the first power minus the second power, which would be d to the negative first power. Negative power means that it goes on the bottom. Okay, if it was d to the positive 1 power, that means that d would be left over on the top. So that's all that negative power means, is that it ends up on the bottom. Same with my a's. I have a squared on top and I have a squared on the bottom. So I'm going to subtract the top power by the bottom power, just like how over here, this is the top power minus the bottom power. There's 2 of them, 1 and 2. Okay, so that's how I get a to the 0 power, or 1, nothing. Ends up not showing up, so they cancel each other out. So it's up to you if you want to expand them out to cancel out or if you want to use a shortcut of the powers. Just remember, if you are using a shortcut with the powers, you have to keep track of where it ends up and make sure you're subtracting the top power and then the bottom power. So the bottom power are subtracted from the top. Okay, let's take a look at C. Whoa, that's a lot. I'm actually going to clear my board then because I'm going to need a lot of space. Okay, let's take a look at C. So I need to, it looks like see how there's adding and subtracting on each of these numerators and denominators? That's a huge hint to me that I need to factor because it's not just one term being multiplied by another. So really, if I were to multiply these together, I would end up not being able to do much because addition and subtraction basically glues this numerator together. So if I were to multiply across, I would just get something like this. Like I can't do much. I would just have to put in parentheses to show these are together and I don't have anything to eliminate. By factoring later, I will be able to break them down into smaller bits, just like how 8 can be broken down into 2 and 4, and then possibly simplify with something on the top. So this means that I need to factor. So let's start off with this first part right here. 2x squared plus xy minus y squared. I'm going to write it up for here where I have space. Something that you might notice right now when you're looking at it is you're noticing that I have an x and a y. And I'll be honest with you, I kind of freaked out a little. I was like, oh my gosh, we haven't covered this. But, cool trick, either the diamond box method or the AC method will actually work with this. It's just a tiny bit more complicated because of the extra variable, but trust that it will work. So let's use the diamond box method, okay? With the diamond box method, you have to find your AC value and then your sum and then your 2 factors that'll make those 2 work. Let me use a different color here. For my AC, I have A, which is 2, and my C value would be a -1. I'm going to ignore the fact that this is a y squared, okay, and that this is an x squared. I don't care about that right now. I'm just looking for my coefficients. Okay, so my AC would be 2 times -1, which is -2. My sum, again, this xy kind of makes me freak out a little, but my sum is still 1. Okay? So just looking at my coefficients. Doesn't change because there's an x and a y. So now I'm looking for two numbers I can multiply to -2 and add up to 1. Well, if I need to multiply to -2, that means one of them is going to be a negative. And if I have to add up to 1, and again, there's only two factors for 2, which is 1 and 2, one of them has to be, the bigger number has to be positive. So it's a +2 and a -1. -1 times 2 is -2. -1 plus a +2 is a +1. So I end up with a -1 and a 2. Now normally we would put an x next to it, yeah? But now we have xy, if you notice, for our middle term. Remember, the whole point of either method is to break down that middle term, right, into two other smaller pieces. These two need to add up to make xy. So all I'm doing is just adding a y at the end, okay? So normally it would be -1x and +2x. Now it just becomes -1xy and 2xy. Not that big of a change, right? Let me go ahead and set up my Punnett square. So as always, I'm going to write down my first term, 2x squared, my last term, -y squared, and now my two diagonal terms, -xy and 2xy. Okay, and then I need to figure out what they have in common. So 2x squared and -xy both just have an x in common. 2xy and -y squared just have a y in common. And then going sideways, 2x squared and 2xy both have a 2 and an x in common. And then these two both have a negative in common and a 1y. So at the end, all this, 2x squared plus xy minus y squared, is really 2x minus y times x plus y. Okay, and then I can real quickly use FOIL to figure out if it actually gets me back to that answer, because I'm like, I don't know, I haven't done this before. 2x times x is 2x squared, negative y times x is -xy, 2x times y is 2xy, and then -y times +y is -y squared. These two will become a +xy because 2 minus 1 minus y squared. Does that get me back to it? Yes, it does. Okay. So it's the same method, but instead you're adding in that y after you did it. It looks really confusing, but again, with the AC and the sum, you're just looking at the coefficient. So that y, that extra variable, only comes in at the very end. All right, so we got that top part for the first fraction. Why don't we figure out the bottom part? So I have 12x minus 6y. I can't do much other than taking out what they have in common, right? It's not in quadratic form, so it's not like I can factor it. X and y don't have anything in common. 12 and 6 have 6 in common, so I can take that out. So it becomes 6 times 2x minus y. And yeah, I can rewrite that here. Okay, multiplication means that it's just going to be multiply across. So at the end, I'm just going to add it onto the top here. So let's figure out this part over here, the numerator for our second fraction. I have 4x minus 4y. There's nothing else I can do other than take out what they have in common, which is that 4. So I end up with 4 times x minus y. And like I said, I can just rewrite it next to the numerator for my other fraction because it's multiplying across. So it'll just end up right next to it. And now I just have one more denominator to figure out, which is x squared minus y squared. Now this is kind of sending off sirens in my head because I see the squares on both of them, so I know it's going to be factoring. I see no middle term, and then technically they have ones in front of them, right? So 1 is a perfect square. So this would be a special case right here, right? I can square root that 1. And with a special case, I know that special cases, they're either going to be repeated in the binomial or it's going to be a positive and a negative. There's no middle term, so I know there's going to be a positive and negative, so they cancel out the middle term. So this is really x plus y times x minus y, a special case. Okay, so I have simplified everything I could. I smushed them together because that's all multiplication is, top times top, bottom times bottom. And let's see if I can eliminate anything. What do we have in common? Ooh, 2x minus y and another 2x minus y. X plus y and an x plus y. X minus y and an x minus y. Oh, so beautiful. All that just boils down to 4, 6, which is what's left over. I can still reduce that, and that becomes 2/3. So this is all just extra fraction work, but with algebraic expressions. All the things that you love, right? Okay, let's take a look now at example 4. These are division problems. So honestly, the only difference is you're going to flip the second number and then multiply. So we can just follow the same thing after we flip the second number. Go ahead and pause the video, try it on your own first. All right, let me rewrite A. 10A over 7B times 5C over 2A. All right, and then I can multiply across. So I have 50AC over 14AB. All right, I can go ahead now and cancel out these A's because I have one on top and one on the bottom. And then it looks like no other variables can be canceled out. 50 can be reduced to, what, 2 times 25? And 14 is 2 times 7. Yeah? So then those two would have 2's that cancel out. So then what I'm left over with for A would be 25C over 7B. And that's all I can do. So that's my final answer for A. Let's take a look at B now. B, I have to flip everybody. Okay, so let me see if I can do that in my brain. Let me try and put my numbers in the front too. So this bottom will be multiplied by this top. You know what? Let me just rewrite it. XY cubed over 24Z squared W. I want to rewrite it because I don't want to make a silly mistake and end up with the wrong answer after all my work. All right, so I have 8. I'll try and put it in alphabetical order. W goes first. W to the 4th power, X, Y cubed, and Z. On the bottom, 24, W, X squared, Y, and Z squared. Okay. So let's see now, what does this become? Let me break this down. Well, 8 is going to share a factor with 24 because 8 times 3 is 24. And then I have 4W. You know what? Let me do my, let me practice my, my little shortcut. Let's do that. So with my W's, I'm going to have W to the 4 minus 1 power. For my X's, I'm going to have 1 minus 2, top minus bottom. For my Y's, it's going to be 3 minus 1. For my Z's, it's going to be 1 minus 2. Oops. Z, 1 minus 2. All right, let's rewrite this then. So my 8s would cancel each other out because I got one on top and one on the bottom. So then that means there are no more numbers left on the top. And then just a 3 on the bottom. Okay, so it's like 1/3 on the bottom. W's 4 minus 1 is to the third power. X 1 minus 2 is to the negative first power. Y 3 minus 1 is positive 2. And for my z, 1 minus 2 is negative 1. Okay, this is not my final answer because I don't like those negative exponents, right? So let's throw everything that has a negative exponent to the bottom because that's all that means. So w to the third power stays on top. Y squared stays on top. And on the bottom, don't forget we have a 3. And then x to the first power, so we don't need to write that one. And z to the first power. And that's all. That's our answer. That 3 was on the bottom. The w was to the third power, so that stays good. Y was to the second power, that stays on top. Anything with a negative power goes to the bottom because that's what negative power means. Negative power means that it is a denominator. And then we don't need the power on the bottom because it's to the first power. And then once it goes to the bottom, it loses its negative sign because we already did that action that shows the negative part. So we have w to the third power times y to the second power all over 3xc. Let's clear the space now for C. So for C, oh, look at that. I see adding and subtracting, so that means we're gonna do some factoring. Let me go ahead and first multiply by flipping. Let me flip the second number and multiply. Make sure everybody is in the correct location. Remember, these stay in their parentheses because they are together. So all I've done so far is just flip and multiply. Okay, and remember, I know I'm going to have to factor because these all have addition or subtraction in between them. It looks like the bottom one I don't have to do much work, right? Because there's not much I can do now with 5c plus d. That's already in its binomial format. So all I have left over is just to factor the top. So they were being kind to us. Let's start off with this first one here. P squared minus q squared. Alarm bells going off in my head because I see perfect squares with a missing term between them. So really this is a plus or minus special case, right? P plus q times p minus q because they have perfect squares there. They have ones which can be square rooted. So this right here becomes p plus q times p minus q. And then we have this last part right here, 25c squared minus d squared. Again, alarm bells going off in my head because I see perfect squares. 25 is a perfect square, and so is this 1 right here. And again, no middle term. They're being so nice to us. So at the end, I'm going to have two special cases, binomials being multiplied together. One is an addition and one is a subtraction. Square root of 25 is 5, so it's going to be 5c over here, 5c over there, and then square root of 1 is just d and d. So I have 5c plus d, and then a 5c minus d. Let's see if anything can be crossed out. 5c plus d, boom, you're gone. P minus q, you're gone. So then at the end, I just have p plus q times 5c minus d.